In this lesson, I want you to graph quadratic inequalities in two variables, and I want you to solve quadratic equalities in one variable. In the first example, we're going to graph this inequality y is greater than x squared minus 3x plus 2. We graph the inequality extremely similar to graphing an equation. The only difference is we're going to have to shade and use a solid line or a dashed line. The first thing I want you to notice you can factor this quadratic. Well, since you can factor this quadratic, it makes it a lot easier to graph. So we're going to go x minus 2 and x minus 1. So we're going to graph the x-intercepts. So the x-intercepts are at 2 or 1. Because remember, x minus 2 equals 0 and x minus 1 equals 0. So I'm going to graph 2 and 1. Well, your vertex is going to be the average of your intercepts. So the average of 2 and 1, well, that would be 1.5 or 3 over 2. I need to find the y, though. So I'm going to say y equals, let's go 3 over 2 squared minus 3 times 3 over 2 plus 2. Well, 3 over 2 squared is 9 over 4 minus the 9 over 2 plus 2. You need a common denominator of 4, so we get 9 minus, well, 2 times 2 is 4. So that'll be 9 times 2 is 18, plus 2 times 4 is 8, all over 4. Well, let me see. 9 plus 8 is 17, minus 18 is negative 1 over 4. So your vertex is at 3 over 2 and negative 1/4. Or it's easier to graph as a decimal, I guess. 1.5 and negative 0.25. So now let's graph that point. So if you go over 1.5 and down 1/4, there's your vertex. Since it's a parabola, we know it's a happy parabola because it's opening up. And we can see the vertex there. It's going to be a dashed line. So let's draw a dashed line through our parabola. We're going to shade above or up from our parabola because it's greater than. So I'm going to shade inside here. Now, sometimes students get confused about up means. The other way you can do it is you can use a test point. Let's do a test point. I'm going to pick a test point of 0, 0. Notice 0, 0 is not on my parabola. So I'm going to use my test point of 0, 0. Let's substitute 0 in for x and y. So we get 0, 0, 0. That's why I like to pick it, because nice things happen. We get 0 is greater than 2. Is 0 greater than 2? That's false. So we don't shade the side with 0, 0, since it's false. We shade the opposite side, which is inside the parabola. When we solve an inequality by graphing, we kind of do the same thing. The only difference is now notice it's less than 0. I'm going to graph this line y equals 0 right here. So any part of my parabola that falls below that line is going to be a solution. So if I take a look at, we can factor this again, can't we? X minus 3 and x minus 1 would be less than 0. So I've got y-intercepts at 3, not y-intercepts, sorry, x-intercepts at 3 and 1. That's going to be my solution, isn't it? But let's take a look at it here. Well, it's be part of my solution. I have to look how my parabola looks. Let's find the vertex. So the vertex, once again, let's use the average of my x coordinates. So x equals 3 plus 1 divided by 2 would be 4 divided by 2, which is 2. Now let's substitute that in. So we're going to get 2 squared minus 4 times 2 plus 3. Well, 2 squared is 4 minus 8 plus 3. 4 plus 3 is 7. Minus 8 is negative 1. So my vertex is at 2 and negative 1. It's a happy parabola, so it opens up. If I was graphing it, I would shade it, but really what I'm looking for is the part of the parabola that is below the x-axis, this part right here. So my solution is x, since it's less than, but not since it's no line under it, it does not include my points 1 and 3. So it goes from 1 to 3. Any value of x that goes from 1 to 3, non-inclusive, is going to be a solution to your inequality. And there you got it.